Hello, my name is Mike Struess. I'm from Milwaukee, Wisconsin. I'm an aspiring data analyst, and in today's project, we are investigating disparities in home mortgage approval. I'd like to continue by looking at a summary of the data set. On the data set, we have the respondent ID, loan amounts, whether they were approved or denied for the loan, the ethnicity or race, gender, income of the applicant, median income for the applicant's metro area, the agency name, type of loan, property type, loan purpose, whether it was their principal dwelling or not, and the loan amount. Before jumping into the detailed analysis, it's crucial to understand the basics of the data set. This step is known as the exploratory data analysis, or the EDA, which helps us get a sense of what we should expect from our tests and highlights any parts of the data that might need cleaning or reformatting to be more useful. One of the first things I noticed in my data set was that I didn't have a clear approved or denied. Every applicant was either approved or denied, but it was kind of written in code. So I had to set up an XLOOKUP function to assign each applicant an approved or denied status. As you see from the left side of the screen, that is what was there as far as action taken. There was a helpful reference table that said what each of those actions stood for. So this XLOOKUP function took the data in column M, action taken, and then matched it up with the action taken row in the action reference table, and then printed what was in this column AB under status. And this is what it printed in column W. Once I had a binary approved or not approved, I did an approval rate pivot table of the entire data set. You can see that I put status name in the rows and approval status in the values, which gave us this table showing that overall of all of the applicants in this data set, 82% were approved for their home loan, 18% were denied. Then I broke the mortgage approval rates down by race. I put the applicant race name in rows, and then the count of the respondent IDs, which would count up how many people are in each of the races in the data set, and the approval status in the columns, which looks like this. I also put conditional formatting on the column labels for approved to quickly highlight what are the highest approval rates, which in this case, the white applicants and the Asian applicants have a nearly identical acceptance rates overall. The bottom two rates would be American Indians and African Americans. Here is a 100% stacked bar chart. From this, you can see 4 of the races in this data set are roughly equal, with the American Indians being a little bit lower, and one of them, the African Americans, are visually a bit lower. Next, let's dive into our bias analysis. When comparing acceptance rates, it might be hard to say this group is getting accepted more than the other group. So maybe if we break down the classes in this data set, that could help us compare apples to apples. You can see in this histogram for applicant incomes that there's a lot of data between 30,000 and 106,000 and a long tail to the right. Those incomes to the right would be incomes of over 3 million. So I used an ifs function to take all of the applicants and put them into one of three categories. This ifs function says if the income is less than 40,000 to attach the name lower for lower class. Then once it's sorted those, any up to or equal to 122,000 would be labeled middle for middle class. And all incomes above 122,000 were labeled upper, which took a column that looked like this and produced a column that looks like that. Note from this, any numbers less than 40 will have lower next to it. There's a few values here that are more than 122,000. Those should all say upper. And middle should correspond as well, between 40 and 122,000. Then I made a pivot table to compare by class. So not only by race, but by race and class. Especially important in this pivot table is that I put class first and then the applicant's race. So now we have the data broken down by the lower class and race, middle class and race, and upper class and race. When breaking it down this way, one weird consistency is that at every level, the percentage difference between African Americans and white applicants is pretty consistently 14%, give or take 0.1%. And I also added some conditional formatting to compare. It's A/B test time. I set up a null hypothesis and an alternative hypothesis. My null hypothesis is that middle-class white Americans have no higher loan approval rate than that of middle-class African Americans. And the alternative hypothesis is that middle-class white Americans have higher loan approval rates than middle-class African Americans. If we compare only the middle-class approval counts of middle-class white people and middle-class African Americans, it looks like this. So of just the middle-class applicants, there were 639 African American applicants in the middle class and 5,292 white middle class applicants. On the right here, we have how many of them were approved. Is the sample size big enough for the test? Well, if we break down that approval rate by percentage, 85% of those white applicants were approved for their loan, and just shy of 70% of the African Americans in the middle class in this data set were approved, which gives us a minimum detectable effect of 22%, which I got by doing the difference of these 2% divided by the lower amount. And putting that into a sample size calculator, it said I would need at least 63 appliers per group. So if we look back to how many people we have in each of the two categories, is the sample size big enough? Yes, it is. In fact, we have 10 times that in each group, at least. So then I put those approval rates into an A/B tester. So this rounded to the nearest percent, so 70% and 85%, which again, our conversion rate or our effective difference between these two is actually 22%. And the A/B tester says, test B converted 22% better than test A. I am 100% certain that the changes in test B will improve your conversion rate. Now, this tester is often used for marketers who are changing something in their app or on their website to see if they can get more people to subscribe or more people to open up their website. It says our test was statistically significant. We can conclude that we can reject the null hypothesis and accept the alternative hypothesis. Middle-class white American mortgage loans are approved at a higher rate than those of middle-class African Americans. The test found with 100% confidence that this was statistically significant at 22%. For further study, we could control for more variables in A/B testing. For example, we could keep type of bank constant, or the type of loan, or the loan amount. We could also control for gender, or credit score, or down payment readiness. We could also look for trends. Is this getting better? Is this getting worse? Where it's at right now obviously isn't acceptable. How does the legacy of redlining play into this, and how could that help us better understand how to fix the problem? For example, it was legal to discriminate against people of color trying to buy a home until the mid-60s. How does that play into this, and how could that inform us on how to get better? Limitations of this data set. It comes from a natural experiment type situation where it's unethical to play with some of these levers, so we kind of have to do it by observation. But if we have a large enough set of data and we control for as many variables, we can get this to as close to an experiment as possible. But as with any experiment, as controlled as you try to make it, there's often confounding variables that could be the real reason why some things are happening. For example, just being coached on what things to have ready to apply for a loan. If you're a third or fourth generation homeowner, maybe you have lots of advice passed down to you. And that brings me to an opportunity from this data set. Education programs, if banks want to make this right. I've seen banks do this, teaching formally at a school with a lot of disadvantaged students. A lot of banks are trying to make this right by hosting, paying for, funding educational programs that teach financial readiness, including how to know when you're ready to buy a home. Another opportunity and thing that this project has brought to light to me is the role of ethics watchdogs in the data analysis world, and how that's potentially an avenue for someone who's good at data analytics. Something I might want to pursue someday. Thanks for watching. I hope you learned something from this presentation. I know I did. See ya.